Welcome back again. Woo! All right, math, indefinite integral. We're doing it. But before we do it, let's start with a joke. Good one, hopefully. Oh, man. All right. What do you call a blind dinosaur? Ready? Do you think he saw us? Saw us? Saw us? Okay. Anywho, back to math. All right. We have been working through definite integrals, right? And defining them between 2 points of x, maybe x equals, a and b, or 1 and 3, or -1 and 2. Now, sometimes we like to generalize things, and we just want to know what happens when we integrate something, okay? So we like to make generalizations. They're not so specific anymore, but we get the rough idea. That's when the indefinite integral comes in. Now, the good news is if you know how to do a definite integral, you definitely know how to do an indefinite integral. All right, there's just a couple little things that we need to remember here. So it just means not defined. And that means when you have the integration, notice how there's nothing here. There's nothing going on there. All right, it's empty, it's blank, it doesn't exist. We're not defining it. Okay. Now, when we do this, okay, just remember, we should know this by now, and I'm just going to write it algebraically. It doesn't make the most sense, but you'll start to see it when the numbers kind of come through. You'll be like, this is familiar. Okay, so if you're integrating x to the n, what ends up happening is you have x to the n plus 1. So you raise 1 to the power, and what do? You divide by that new power, n plus 1. Now, the only difference is when there is no definition, when you have no values of x to integrate it between, you've got to add this thing called plus c. Okay. Now, same thing here. If we start to get ax plus b, so some sort of bracketed, it's kind of like the reverse chain rule almost. This is how it's going to look. You're going to have your original bracket, right? You raise it to the power of 1. And you now divide it by that new power of 1. The only difference now is you multiply it by the coefficient of x, or in this case, it's actually the differentiation of the top bracket. Okay, now all these letters will hopefully clean themselves up a little bit. And again, with an indefinite integral, we need that plus c. Okay, why the plus c? So if I said y equals to x squared plus 1, or y equals to x squared plus 2, or y equals to x squared plus 10 times 10, 100. So why the plus c? If I do my differentiation here, if I go y dash, I'm going to get 2x here. If I do my y dash here, I'm also going to get 2x here. If I do my y dash here, I'm also going to get 2x. So that means if I integrate 2x dx, it could technically be either one of these, right? It's going to be x squared. It could be x squared plus 1. It could be x squared plus 2. It could be x squared minus 100, minus 1, minus 2. It could be anything, but we kind of get the rough idea. We get a general idea. It's going to be an x squared, and it's just going to be moved up or down slightly. Okay, so that's why the plus c exists, because, when you differentiate a number, it kind of disappears. So we're just kind of accounting for that. Right. Now, the best way for me to probably show you is let's do some examples together. I'm going to zoom past these, and this is on video, so you can pause it at any time to make sense of it. I'll do my best to explain. Now, integration of 8x cubed dx. This is going to be, all right, 8x. I'm going to raise x to the power of 4. I'm going to divide by that new power plus c. Clean it up a little bit. That becomes 2x to the power of 4 plus c, because I just canceled out the 8 and the 4, or simplified those. Okay. Question B. Now, this is the kind of like the reverse chain rule we were talking about. If we've got a bracket that's raised to a power, what ends up happening is I'm going to have that same bracket, 2x plus 7. I'm going to raise it to, I'm going to raise the power by 1, so now it's to the power of 5. Now it's also going to be divided by that new power of 5. Now the only thing is, whatever the coefficient of x is, that comes down here. Okay, so it becomes 2 times 5. So again, plus c. Once you clean it up, it's going to be 2x plus 7 to the power of 5 over 10 plus c. Okay. Now, if we deal with negative indices, now I'm going to change the color because I realized that looked a little bit messy. Okay. If we're working with negative indices, let's move them into something that we're familiar with before we start to integrate. Okay. It's a bit difficult this way, but if I wrote it as a negative indice, hopefully you remember that is what a negative indice is. If it's a positive indice as a on the denominator of a fraction, it just means it was a negative indice as a non-fraction. Okay, so you've got 4x to the negative 5. That's what we're essentially dealing with here. Now just be careful when you're dealing with this. Now your 4 stays the same, your x is going to be the same, but if I add a power to negative 5, I want you to think negative 5 plus 1. Okay, now what's negative 5 plus 1? Some of you guys would be thinking negative 6 because the numbers always increase, but negative 5 plus 1 is actually going to be negative 4. Okay, negative 4. And what do you do once you've raised it to a new power? You divide it by that new power. All right, and again, cleaning that up, negative 4 and 4 will cancel out. That just leaves me with negative x to the negative 4 plus c. There you go. And for this one here, if you've got a question like this, dx over 3x minus 2. Now this is the same thing as, and I'm going to write this down because it'll be helpful. It's the same thing as saying 1 over 3x minus 2 dx. Okay. Some people freak out. It's like, oh, now the dx is on top. It's not on the right. It's the same thing, just written differently. Okay. Now, if I'm looking at that, whoops, I wrote integration equals integration. That's better. Now, it's the same thing. This is the same thing. Remember, if it's 1 over something, essentially what it is, I'm going to change the question slightly. Okay. I want to edit that out, but that's fine. It's okay. I'll explain what that one is later and why this couldn't work. Maybe in class I will. But for the time being, let's work with this. So now what we actually get is it's the same thing as saying 3x minus 2, and it's to the power of negative 2 dx. Okay, so if we were to integrate this now, let's go, it'll be the same bracket. Man, that one frazzled me. But it's fine, we can move on now. It's going to be 3x minus 2, the same bracket. Now we're going to add 1 to the power, so it's going to be negative 1 now. And we divide it by the new power, which is negative 1, and we're going to plus c. Now, if we divide something by negative 1, it just becomes negative 3x minus 2 to the negative 1 plus c. Happy for you to leave it like that. Now, we've got 4 more, so hang tight with me. Sometimes we'll have special cases, right? If we've got x cubed plus 2. Now, notice this is not in the form of, and again, let's use different color. It's not in the form of ax plus b, right? Because it's an x cubed, so it doesn't quite work here. So if you've got anything that is not a square root, is not just a singular x, we're going to have to deal with this differently. Okay, now if we're dealing with a squared here, what I would be doing is I would be expanding this out as if it was a perfect square. So I'm not going to go over that today, but you should know that it should be x to the 6 plus 4x cubed plus 4. Right? If you're not sure on what I did to get there, expand it out. Go x cubed plus 2 and then multiply it by x squared plus 2. Okay. And then you do the whole FOIL and the whole expanding brackets. Now, once we got that, this becomes a lot easier. You integrate term by term. So it's just going to be, okay, x7 on 7 plus 4x raise the 3 to the 4, or raise it to 1 power, divide by the new power. Right, and if it's just a singular number, you add an x to it. Right, now all of this is going to be plus c. And cleaning up again, we want to make it as clean as possible. That just becomes x to the 4 plus 4x plus c. That's your integration. Okay. Now, again, if you've got something here on the right-hand side, I hope that you recognize 6 and 1 on x, 6 and 1 on x. The only difference is one is plus, one is minus. That is what we call a difference of two squares. Okay. So again, if you don't remember what a difference of two squares is, have fun expanding it. If you do remember, it just means it's the first term squared. So it's going to be, in other words, 6 squared. And it's going to be take away 1 on x squared. Okay, that's your difference of two squares. All right, now let me clean that up a little bit. That's going to be the integration of 36 take away 1 on x squared dx. Right, so if I do this, let's integrate term by term. 36 becomes 36x. Draw a little line here. I'll move that plus c in a little bit. Again, edit that out. So 36 now becomes 36x. And then this is going to be, let's take one more line here just so we can really know what's going on. So this now equals the integration of 36 take away x to the negative 2. Okay. Now this becomes 36x. That one's nice and easy. But now this one becomes negative x to the negative 1 all over negative 1 plus c. Right. And again, to finally clean that up, that's just 36x. And it's going to become plus x to the minus 1 plus c. Okay. Your textbook will likely change all negative indices back into positive indices. So it'll look like this. Okay, 36 plus 1 on x plus c. All right, last ones. Well done for hanging on. Hang with me. Now, you just have to remember, how do fractional indices work? That's going to be something that you might need to recap from year 11. If we have the square root of x, that's the same thing as saying x to the positive half. Okay. And so let's try to work this through. If I add 1, what's 1 plus a half? Well, it's going to be 3 on 2. And then what am I going to divide it by? Well, I'm going to divide it by 3 on 2 plus c. And so if you do your arithmetic here, don't just follow a pattern because you understand or because you think you've found a pattern. Make sure you know what you're doing. If you're dividing x by 3 on 2, I understand it as, or it's going to end up becoming times 2 on 3. So the 2 kind of jumps to the top. So it's going to be 2 times x to the 3 on 2 all over 3, okay, plus c. So that there becomes your answer. Now again, if we've got this one h, remember this is the exact same thing as saying 1 over, and I'm going to write like this, 1 over 2x minus 3 to the power of half dx. Right, same thing, just a different way of writing it. I shouldn't have written dx. That's fine, just like that. Okay. Now, when we want to integrate this, let's change it one more time. It's the integration of 2x minus 3. And because the power's on the bottom, it's 1 over. It's the same thing as saying it's to the power of negative half dx. Now, let's see if we can do this. Let us raise it to the power. Let's add 1 to the power. What's negative 1 plus 1? Actually becomes positive half. I don't know why I'm integrating anymore. Don't need the integration sign because now I'm actually doing the math. Now I'm adding 1 to the power. So guess what? I'm going to divide it by the new power. And I'm also going to multiply it by the coefficient of x, which is going to be 2. Okay, so what's nice about the denominator this time is half times 2 is just 1. So my answer becomes 2x minus 3 to the power of half plus c. And remember, anything to the power of half is the same thing as a square root. Okay, sorry if I trailed off, but there was a lot of examples that I wanted to get through. Hopefully this helps you with every type of question that you might see in your exercises. Any questions, again, let me know. All right, I'll see you guys later. Have fun. Bye-bye.